Where is the function f of x equals the natural log of tangent square of x discontinuous? The thing to consider about this problem is, well, first the natural log function. This function is continuous on its domain. So if you look at the natural log of x, its domain is all positive numbers, and it's continuous on that domain. And composed within that function is tangent square of x, which is the same thing as saying you're squaring tangent, and tangent is defined as the ratio of sine to cosine. So if you see tangent square of x, it's really the same thing as this. We can put all of these pieces together to figure out the discontinuities of this function. So to start with, the function f of x is really the same thing as the natural log of sine of x divided by cosine of x squared. Now, wherever cosine is equal to 0, you're going to have a 0 in the denominator of a fraction. And this is going to be a place where this function is not defined and therefore not continuous. So we want to eliminate all places where cosine of x is equal to 0. Again, the reason for that is if the denominator here is 0, the function's undefined, and therefore this thing is not continuous. Now, the places where this happens are when x is equal to plus or minus pi over 2, plus or minus 3 pi over 2, and actually all odd multiples of pi over 2 forever. So we want to eliminate all of these values. We cannot put them into this function because you'll be dividing by 0. But there's something else we have to look out for too. If this entire thing within the natural log function is ever 0 or negative, we want to eliminate those as well. You can't put 0 or a negative number into the log function, so that means this thing can't be 0 or negative. Now, the good news is that if you look at tangent square of x, since you're squaring tangent, there's no way it can be negative, but it can be equal to 0. So we need to find all the places where tangent is 0. Tangent squared will never give you a negative number. The only issue could be is if this happens. So where does tangent square of x equal 0? How can we figure that out? That's where sine divided by cosine squared is equal to 0, and a fraction is equal to 0 if the numerator is 0. The second place we have to check is where is sine of x equal to 0? So we found these. We now need to find these values. Sine of x is equal to 0 if x is equal to 0, plus or minus pi, plus or minus 2 pi, and so on. 3 pi, 4 pi, going on forever. So here are all the places where this function is discontinuous. And this function's continuous everywhere else. And the reason is, at all their numbers, sine and cosine are continuous. If you divide them, they're continuous. If you square it, it's continuous. And if you compose a continuous function into another continuous function, it's continuous as well. So it's just all these numbers and all these numbers that we want to throw away. Now there's a nice concise way to write this. We can consolidate these two lists together. So we can write all the places where it's not continuous on the same list. So here's how you could do that. So if we want to put these together, the numbers that don't work are, well, you can't have 0. You can't have plus or minus pi over 2. So here 0 came from this list, pi over 2 came from this list. And here we'll jump back to this list and we have pi. But pi is the same thing as plus or minus 2 pi over 2. The next one will be plus or minus 3 pi over 2. Then we want to eliminate plus or minus 4 pi over 2. And we want to eliminate plus or minus 5 pi over 2. And I can see the pattern now. All we have to do is write our solutions as x is equal to n times pi over 2, where n is an arbitrary integer. What this will do for us is, if n is 0, we'll get 0. If n is plus or minus 1, we'll get plus or minus pi over 2. If n is equal to plus or minus 2, okay, well, we get plus or minus 2 pi over 2, which is the same thing as pi because the 2 cancels. Then if you put a 3 here, plus or minus 3 pi over 2 will give us the solution. If you put 4 in place of n, a plus or minus 4, you get plus or minus 4 pi over 2, which is the same thing as 2 pi. So if we do this forever, these are the answers that we're looking for. Now, in terms of the graph of this function, it's quite a complicated equation. So the natural log of tangent square of x. I actually just graphed this thing at Desmos, and I changed the axis so instead of integers, it was multiples of pi over 2. And so we want discontinuities again at 0, pi over 2, pi, 3 pi over 2, and also all their negative values as well. And the thing that you can see on this graph is, oh, at all those numbers, there's a vertical asymptote. Sometimes it's going down to minus infinity. That's happening at the multiples of pi. And sometimes it's going up to positive infinity. And that's occurring at the multiples of 3 pi over 2, negative 5 pi over 2, and so on. So it's continuous everywhere else. And this is how you get the graph of the function.